Okay, so we are going to do a quick demo or experiment with some magnetic marbles to demonstrate what is going on with the molecules during a phase change. So first of all, we have this key concept number 6. We've already written it down. This is just a reminder. When energy is transferred to or from a substance, it can change the molecule's freedom of movement. So you can add energy to increase the freedom of movement, or you can remove energy to reduce the freedom of movement. Today, we're going to look at what actually happens to molecules when energy is added or removed. So, question 62 is about our investigation question. Why can transferring energy into or out of a substance change the molecule's freedom of movement? 63, we have three claims of what could possibly answer our investigation question. I want you to write out which claim you think is the correct answer. So, claim number 1 says transferring energy into or out of a substance changes its temperature, which changes the molecule's freedom of movement. Claim number 2, transferring energy into or out of a substance changes the molecule's kinetic energy, which changes their freedom of movement. Claim number 3, transferring energy into or out of a substance changes the molecule's speed, which changes their freedom of movement. Which of these three do you think is correct? So we're going to gather evidence using a little container with magnetic marbles in there. Each magnetic marble represents a molecule. Couple safety guidelines. First of all, container lids should remain closed. We have taped them closed. Leave them taped closed. Keep tablets and computers away from this activity. Do not put marbles near or in your mouth. These are dangerous to ingest. They literally could rearrange your intestines. So don't swallow them. Don't open the container. Don't do anything that you're not supposed to. So we've got this little container of marbles. How could we add energy to this container? Well, we're going to represent heating it up by having it move. So here, I guess I'll go back to the screen and zoom in. Here we have the marbles. It's kind of hard to see from your angle. If they're moving slightly, they have some energy, and the molecules are essentially just moving in place. They're all move around the container together, but they all stay in the same position relative to each other. If I start adding more energy and moving them around a little more, they can start interchanging their spots. They move more and more and more. If I want to add more energy, they start moving faster and faster and faster until they can start breaking this attraction. So if you add enough energy, they end up expanding outwards to fill the whole container because they start bouncing around severely. You add a little energy and they can just mix together. That's like a liquid. You add a lot of energy and they expand outwards and take up the whole space of the container. So I'm going to go ahead and do this activity. You're going to try shaking a little bit, adding a little energy, adding a lot of energy, and experimenting to see what happens to the molecules. For 64, you need to describe how transferring energy into the system changed the speed of the molecules. So the more energy you added, the faster they went. As the speed changed, what did you notice about the freedom of movement of the marbles? Hopefully, as the speed increased, their freedom increased. Did your observations provide any support to any of the three claims discussed up here? Okay, next, what I want you to do with a partner, you don't need to write this in your notes, just talk it over. How would this modeling activity with the marbles have been different if we had stronger magnets with more attraction in between the molecules? So, really, really strong magnets. How would that have been different? How would this experiment have been different if we had weak magnets with little or no attraction between them? And then, how do you think this idea of strong magnets versus weak magnets relates to real substances? Okay, the next part is guided notes 64 part D. This wasn't in the notes previously, which is why it said not in notes, but I just erased that because I added it in part D. So for part D, I want you to pull up the sim. Right underneath the four possible substances, it says what level of attraction the molecules have towards each other. It says like weak attraction, strong attraction, middle attraction. I want you to look at these four different substances and the four different attraction levels and tell me, how does the attraction level affect the states of matter of each of the four substances? How does this affect the temperature at which the freedom of movement changes and thus their state of matter? These are a little bit of a difficult question, but I just kind of want you to explore the sim and think about, how does the attraction level affect the temperature at which they change states?